Hi, good evening, everyone. We'll go ahead and take some more stats questions today. I hope you have done the questions I had given you in the previous class. Go ahead, give this question a try. One of the reason why sample median is used as an estimator of population mean is that. What is the advantage of sample median? Okay, very good. That is the right answer. There is no, no difficulty in answering this. So sample median is unaffected by extreme value. Median में कभी भी extreme values नहीं आती हैं. It is always the 50th, the number that is cutting the data in 50th part, 50% here and 50% here. So therefore, yes, the answer would be C. Go ahead, give this question a try. X is a random variable. X follows a uniform distribution between -1 and 1. You have to find covariance between X and X square. Give it a try. Okay, how about others? Okay. So there are two ways to think about this question, okay? The first way, okay. There are two ways to think about this question. The first way to think about this question is to go ahead and to use the formula, right? And the second way to think about this question is that whenever we talk about covariance, covariance is always accounting for your linear relationships. It does not account for non-linear relationship. That is another way to think about it. But if I actually use the formula also, then also I should be able to prove the same thing. मेरे को एक same answer आना चाहिए. So how do we find the covariance between two variables x and y? It is expected value of xy minus expected value of x into expected value of y. ऐसे covariance निकलते हैं. So if I were to find the covariance between x and x square, it will be expected value of x into x square minus expected value of x into expected value of x square. This will be expected value of x cube minus expected value of x and into expected value of x square. Now, whenever you have uniform distribution, what is the formula of expected value? What's the formula of expected value? Usually also, how do we find expected value? The formula of expected value of any variable. अगर मुझे किसी भी variable का expected value निकालना है, it is x fx dx integrated, right? This is how you find expected value. So if I were to go ahead and if I were to find the expected value of x cube, it will be x into x cube, क्योंकि x cube का expected value निकालना है. So it will be x cube into its probability density function between -1 to 1. अगर x का एक्सपेक्टेड वैल्यू निकालना है, इट विल बी x इंटू PDF ऑफ दिस बिटवीन -1 to 1. अगर x स्क्वायर का एक्सपेक्टेड वैल्यू निकालना है, इट विल बी x स्क्वायर fx dx बिटवीन -1 to 1. दिस इज हाउ वी फाइंड एक्सपेक्टेड वैल्यू. जिस भी चीज का एक्सपेक्टेड वैल्यू निकालना है, इफ आई वांट टू फाइंड एक्सपेक्टेड वैल्यू ऑफ x क्यूब, it will be x cube into PDF. If I have to find expected value of x, x into PDF. If I have to find expected value of x square into PDF, right? And what is PDF? वो भी हमें पता है कि for uniform distribution, we know fx, how it can be written? 1 upon b minus a. So we know it can be written as 1 upon b is what here? B is 1 and A is -1. So कैसे लिख सकते हैं इसे? 1 upon 1 minus -1. That means fx is nothing but half. बस, just put it here. So what will you get? X cube into half का integration. X into half का integration. X square into half का integration. And solve this. That's it. So even if you don't know how to go ahead and how to solve, अगर ये hit नहीं हो रहा कि one of them is, I'm trying to find a non-linear relationship and the non-linear relationship will give me covariance as 0. Suppose ये hit नहीं होता, then you can go ahead and you can use this formula also. Right? And covariance का formula you need to remember expected value of xy minus ex into ey. And expected value का formula you need to remember कि whatever expected value we go ahead and we find out, it is x fx dx integrated. And for uniform distribution, fx is nothing but 1 upon b minus a. So these are some things that you have to remember. But now you can go ahead and solve this. So if I go ahead and if I solve this, I will get x by 4, this between -1 to 1 minus x square by 2 between -1 to 1 into x cube by 3 between -1 to 1. So 1 minus -1, this will simply be 0, minus 1 minus 1, this will also be 0, answer will be 0. You'll get the answer as 0. That's the answer to this question. Okay. Okay. So please keep this formula in mind. Write this down somewhere. It is very useful formula. Keep this formula in mind. How to convert expected value in form of integration. Okay. Try and do this one. Give this question a try. Okay. Good. Very good. Yes. All of you are correct. That is the right answer to this question. So, देखो. See, Z of, when we find Z का value at 99% confidence interval, 2 tailed में कर लेते हैं. So it is 2.58. And when we find Z at 95% confidence interval, again 2 tailed में, it is 1.96. So if I were to find the confidence interval of, suppose confidence interval of mean, ठीक है? तो mean का confidence interval will be what? It will be sample mean minus plus standard error into the value of Z. Into the value of Z. So it means it will be mean, sample mean minus standard error plus standard error अगर 95% है तो it will be 1.96. And if it is 99%, it will be 2.58. Right. So you understand the difference. यहाँ पे I am adding 1.96 times this. यहाँ पे I am adding 2.58 times this. माने मैं ज्यादा नंबर ऐड कर रही हूँ. I am adding more. Similarly, here I am subtracting 1.96 times standard error. Here I am subtracting 2.58 times standard error. So I am also subtracting more. So it means that when we talk about this, अगर मैं इसके कंपैरिजन में इसको देखूं, वी आर सब्ट्रैक्टिंग मोर हियर एंड वी आर एडिंग मोर हियर. इट मींस दैट वी आर क्रिएटिंग अ वाइडर इंटरवल. हम ज्यादा ऐड कर रहे हैं ये वाला साइड पे एंड हम ज्यादा सब्ट्रैक्ट भी कर रहे हैं. सो वी आर क्रिएटिंग अ वाइडर इंटरवल. सो यू आर करेक्ट. यस, द 99% confidence level will be wider as compared to 95% confidence level. That is the correct answer. Okay, come to the next question. Try this one. Very easy. This is just the formula of chi-square. Okay. How about others? Let x1, x2 be random sample from normal distribution with parameter mu and sigma square. Then the random variable, you're given a random variable, has a chi-square distribution with n-1 degrees of freedom. We know this thing, right? Now it says here x bar denotes mean of this. Suppose area under chi-square with n-1 degree of freedom to the right. Area to the right. It is given as degree of freedom n-1. Okay. Now we want to create 100 1 minus alpha % confidence interval for the variance. So we want to create 100 1 minus alpha % confidence interval. अब एक बात बताओ, tell me something. Whenever we create confidence interval, one thing that we are sure is that, so this is, suppose this is a confidence interval. So this will be my upper limit and this will be my lower limit. It means I need a smaller number here. And I need a larger number here. पहली बात तो ये. Secondly, of course, since the formula is n-1 s square, since the formula is n-1 s square, it means that I will have n-1 s square only. I cannot have n s square. So it means that automatically options C and D are eliminated. I cannot have n s square. ये तो नहीं हो सकता है C and D. The only two options that are left up to me are option number A and option number B. Now, I want a small, so जो पहला value होना चाहिए before comma, I need that to be a smaller value. The value will be a smaller value if the denominator will be larger. When will I get a smaller value? The more the denominator, जितना ज़्यादा denominator होगा वो उस पूरी value को नीचे कर देगा. It will fall, make it come down. So basically, we want to go ahead and we want to compare the denominator. One is chi square alpha by 2 n minus 1 and one is chi square 1 minus alpha by 2 n minus 1. We want to compare the denominators. That is what I want to do. Now, suppose I take alpha. Suppose I take alpha to be 5%. So what will I go ahead and what will I get here? It means I am evaluating this. 5% means 0.05. So I am going ahead and making 95% confidence interval. I am finding 95% confidence interval. Here, if I take alpha to be 5, if I take alpha to be 5%, so this will be my chi-square value corresponding to 5%. And this will be my chi-square value corresponding to this. Isn't it? This will be my chi-square value corresponding to this. So which value do you think? Here, 2 is here, huh? Just here. Which value do you think is smaller or larger? Which value should be larger? What do you think? This value or this value? What happens to chi-square? Which value do you think would be a larger value? Quickly, can you go ahead? I don't have table here. I won't be able to print the table in my tab, right? Can you quickly open the chi-square table if anyone has access to it? Just quickly open the chi-square table. This is something you should be very clear with. Let me see if I can somehow share it on the screen. Open the chi-square table. Quickly open the chi-square table. Just Google it. Open chi-square table. And for chi-square table, just go ahead and find the value of these two. Take n to be any number. Suppose take n to be 10. So find out chi-square for 0.05 by 29 and find out chi-square for 1 minus 0.05 by 2 comma 9. That means find out chi-square for 0.025 comma 9 and chi-square for 0.975 comma 9. ये दोनों values मुझे देख के बताओ from the table. I won't be able to open Google here, but just go ahead and just find out these two values and try to tell me what values you are getting. You have to be very clear with this thing. Okay. $19.023 and 2.70. 2.70. Is this correct? These are the values you are getting. Now compare. Now tell me which is a greater value. This is a greater value. So if this is a greater value and I need greater value in the denominator ताकि वो value कम हो जाए, which one do you think should be the answer? A. This will be the answer to this question. This is how you can go ahead and interpret it. I want a greater denominator. Denominator जितना बड़ा होगा वो मेरा lower limit बनेगा. Denominator छोटा होगा तो value बड़ी होगी. That will be my upper limit. So now I want to see which value is coming out to be greater. When I find out this value, I just took some example. I am getting this. When I find out this value, I am getting this. It means, and this is very important, now you can just generalize it and you can keep it as a rule. This means that this is greater than this. तो जो भी ग्रेटर है वो हमें डिनोमिनेटर में ग्रेटर वैल्यू लेके आना है अपना लोअर लिमिट बनाने के लिए. सो विच मीन्स दैट दिस विल बी कमिंग इन द कॉन्फिडेंस इंटरवल लोअर लिमिट and this will be coming in the confidence interval upper limit. Okay, so the answer to this question should be A. Answer will be A. Is this clear now? Anyone who still has a doubt in this? Okay, let's move on to the next question. Do this question.